All right. So, hello and welcome everyone. We are live right now. Okay. So, I welcome all of you. I hope I'm audible to all of you, right? Great. So, so this is the lecture on revision for the chapter of sequence series, right? So, this particular topic or the lecture is going to help all of you who are currently preparing for the JEE mains first attempt. And through these lectures, I am trying to help out all of those students who are preparing for JEE mains first attempt in form of small revisions, right? So, in this revision classes, what we are trying to do is that we are trying to discuss all the important topics, and every topics we are also going to discuss about how to solve the questions that are basically very much relevant for the JEE mains paper, right? So for the ease of the simplicity, what I have done is that I have taken a few questions which we will discuss throughout the class, and along with that we'll quickly recap of the entire syllabus, right? So that would be my attempt over here, right? So let me quickly brush upon the theories. So in sequence series, what you have to analyze, the most important things is basically the understanding of the progressions, starting with arithmetic progression, where each of the terms in arithmetic progression is basically given as a plus r times d, where d is the common difference and a is the first term. Okay, so this is how we write the any r plus 1 term of an AP. Similarly, there is the concept of summation of all the terms or all the n number of terms, then that result is given as n by 2 into 2n plus n minus 1 times of d, which can also be given as n by 2 plus multiplied with first term plus the last term, right? And this can also be given as the summation of equidistant terms from the beginning and the end. So if I consider t of r plus t of n minus r, so this is going to be the same thing, right? So this is basically for the recapitulation of the summation of the arithmetic progression. Now along with that, we also have to take care about another important progression, that is geometric progression, right? So geometric progression or GP is such a progression where the consecutive terms are given by the uh, common ratio, right? Where if I write the t of r term, that will be given as first term multiplied with the common ratio whole to the power. So let me use the letter n over here for sake of simplicity. So it will be r to the power n minus 1, right? And similarly, if I want to find out the sum of the n terms for case of an GP, so the result is very simple, a into r to the power n minus 1 whole divided by r minus 1. So this is the important results, right? And similarly, we'll have harmonic progression, which is nothing but the inverse of arithmetic progression. So harmonic progression from here can be thought of like it isn't just an inverse, it is actually an inverse of AP. So all the results of AP is just reciprocal in case of harmonic progression, so we don't need to study it separately. Okay, now another important result that you need to study as a combined approach of these two is basically called as arithmetic geometric mean, okay, or arithmetic geometric progression, okay, which is also known as AGP. So arithmetic geometric progression is basically a kind of sequence where you have the number as like this, and so on, right? So this kind of progression where you have an AP as a form of this part and a GP where is a form of this r square and so on, right? So this kind of progression is called as arithmetic geometric progression, right? Now the question that will be asked over here is to try to take the sum of this particular results, right? So the way to solve this kinds of problem is that we assume for n number of terms like this, what we do is that we try to write the similar expression but just with a shifted approach, right? Like this. Okay, what we do is something like this. So and after that we need to multiply with r, so like this, and then we try to subtract it. So we will get the result as 1 minus r into s of n, which would be equals to, so this will be result as, so this ar will get cancelled out and we'll have r times, so d will taken out as constant, so we'll have r plus r square and so on up to the nth term, right? So this is basically going to be a GP. This is basically going to be a GP which you can easily take out the sum, and from here you can easily solve for this particular result, that is s of n, right? So from this result you can solve for any arithmetic geometric progression, right? And generally if you take it to infinity, then the sum of this result is basically very simple. It is given as a by 1 minus r plus the common difference multiplied with the ratio, common ratio, divided by 1 minus r whole square of it. Okay, so this is the result for infinite terms of an arithmetic geometric progression. Okay, so these are the important results that we need to take in mind, right? Along with that, there are results for arithmetic mean, geometric mean, and similarly there are certain miscellaneous sequences, like for example, if I give you the sum of the n natural numbers, okay, sum of the n natural numbers, okay, this result is basically n into n plus 1 by 2. Similarly, sum of the square of n natural number, then the result is n into n plus 1 into 2n plus 1 divided by 6. Similarly, the cube of first n natural number, then that is given as n into n plus 1 by 2 and whole square of it. Okay, so these are the important results that we also need to take care, right? And however, solving questions of sequence is basically quite an interesting method, and however we need to use different approaches to every question, right? And among that, one of the approach of method of difference is quite an useful approach, right? So we'll try to see that approach throughout the questions. Okay, so I hope this quick recap of the chapter is clear to all of you, right? So with this recap, let us dive into solving questions. Okay, so this is the very first question that is on your screen. Okay, so please try to solve this problem and do let me know what you are getting in terms of alpha and beta. Okay, so I would request all of you to solve this problem. Please try to solve the problem. Please try to solve this problem. Okay, so if you recall in this problem what is basically being asked, so in the first part it is said that it is already mentioned that 1 upon 1 by 4 plus 1 upon 2 to the power 4 and so on up to infinity, the summation is already given as pi square by 90, right? So this question is not an you don't have to derive this expression, it is already given to you, right? However, you have to approach the sum of the, if I take from here the odd terms, then that is basically given as alpha, and from here if I take the even term, then that is given as beta. So you have to separate the odd and the even terms, right? So how do we do that? So the simplest approach that we can use over here is that, so in order to solve this problem, what I'm going to use is that I will take this particular expression. So if I do alpha plus beta, we'll have the result as pi to the power 4 by 90, right? All right. Now I have to separate out alpha and beta from this particular expression, and that can be done as, so if I take a beta, if I take the term beta, so that can be, so if I take 1 this 2 to the power 4 as common, so that is 1 upon 16, if I take this as common, then the result is 1 plus 1 by 2 to the power 4 plus 1 by 3 to the power 4 and so on up to infinity, right? Which is nothing but this is also known as a result, that is pi square by 90, right? And this is basically equal to beta. So what I obtain is that I will get from here the value of beta as pi square by 90 multiplied with 1 upon 16, right? So from here, then I can approach alpha as pi to the power 4, pi to the power 4 by 90 minus beta, which is again pi to the power 4 by 90 into 1 by 16, which is, therefore this part is going to come out as pi to the power 4 by 90 into 15 by 16, right? 15 by 16. So if you divide this ratio, you're going to get the answer as simply as option number D, which is 50, which is a very simple problem to begin with, right? However, I took up this question just to explain you that sometimes when you have to separate the even and the odd term, however, the even term, if you take 2 to the power that particular term as common, you're definitely going to get the result of the odd terms or the complete series. Okay, so that is a very important idea that I want to present through the help of this question. Is this part clear to all of you? Is this question clear? Do let me know in the live chat, is this question not clear or not? Okay, is this part clear to all of you? Okay, so if this part is clear, let's now move towards the next problem, that is this one. So try to solve this problem. All of you, please try to solve this problem. Please try to solve this problem. Okay. So if you look into this problem again, it's a simple problem where it is said that the terms are in AP, right? So A of n be the nth term of an AP, but the summation of this nth term is given as 700 and A6 is given as 7 and the summation of 7 term is given as 7. So to find out what is an equals to, right, in this case. So beginning with, let us consider the first term as n and the common difference as d, right? So therefore for writing the sixth term, it will be basically a plus 5 times of d, which is equals to 7, and similarly for the sum of the 7 terms, this can be given as a plus the last term, which is basically going to be a plus. Here I will get two equations. So first equation is a plus 5d is equal to 7, and the second equation is 2a plus 6d is equals to 1, right? And sorry, is equals to 2, and therefore from here I can write a plus 3d is equals to 1, right? So if I just simply solve this two equation, I'm going to get the common difference as, so from here I'm going to get the common difference, which is very simple. It is definitely going to turn out to as 3, right? And similarly, if I get the common difference, the first term is going to come out as minus of 8, right? From here you can simply get this result, right? So similarly from here, if I solve this equation for n number of terms, that is n by 2 multiplied with the first term, which is minus of 8, plus the nth term, so n minus 1 times of the common difference 3, and is equals to 700. So from here I will get a quadratic equation in n, and solving this quadratic equation in n, I will get to the value of this n. Okay, so if you solve this value of n, you will get two roots. One is 25 and another root you will get as 5 minus of 56 by 3. Now since the number of terms cannot be negative, so it doesn't make sense, so we have to take off only the positive value, so that is basically going to be 25. Okay, so with this we'll have a of n. So from here, don't get very happy by getting the answer as 25. The answer is to be a of 25, so that will be minus 8 plus 24 times of 3, so which is going to come out as 64. So ultimately the answer to this question is going to be option number D, that is 64. Is this part clear to all of you? Is this part clear? Is this question clear to all of you? Okay, do let me know in the live chat. Are you able to get to the solution or not? Very simple problem, just a recap. Okay, so let's quickly go to the third problem. Okay, now this problem is again a very simple problem, again of GP. We have to quickly recap the GP and try to solve this problem. Okay, try to solve this problem. These kinds of problems might create confusion in the examination hall. That's why I'm showing you these problems. Okay, however, these questions are very simple, but the thing is that people tend to make mistakes in simple problems. That's why the reason to understand is this problem, right? And also there are certain easy results, okay, which we can try to approach this problem too, right? So maybe understanding this problem would actually help us, right? Because this problem might look very simple, however it might get very difficult in the exam hall, right? So that's the reason for showing this problem. Okay, so if we look at this problem, we have been asked with the GP, right? So if you said that the term of the first term, say fourth term, and the sixth term, oh sorry, so the summation of this result is given as 21, and the summation of this 8th term, the 10th term, and the 12th term is given as 15309. This is a fantastic thing, right? This is the beauty of GP. The initial terms are very small, and as you go longer, or as n increases, the number of terms increases very large, right? And also it is said that, so from here what I can do is that let us consider this my first equation and this my second equation, right? So to proceed with this question, if I just divide this second equation with the first equation, if I just divide the second equation with the first equation, what I will get is that, so if I take AR to the power 7 as common from here, and the denominator if I take a to the power 5 common, so I'm going to get the result as sorry, AR common only from the denominator part. So the result I'm going to have is 1 plus AR square plus, sorry, A is already taken common, so 1 plus R square plus R to the power 4 and divided by 1 plus R square, so and R to the power 4, this is which is going to cancel out, and we are going to have this result to come out as 729 now, right? So the beautiful part of this problem is to approach it like this, right? So people are very afraid to solve this question when they see very big numbers, right? So you don't have to get afraid seeing this big number. So the easiest way to solve this is just by dividing this to expression, and from here you'll get the value of, so from here if I divide, you'll get to the value of R to the power 6 as 729, right? So from here you'll get the value of the common ratio, that is the R, coming out to be 3, right? So from here you can easily find out the sum of the 9 term, or the first 9 terms, then that is going to be A into R to the power 9 minus 1 divided by R minus 1. So having this common ratio, we can find out this first term A, so that will be from this equation, so we can do that. So we'll get the first term to come out something as, we will have the first term, so if you solve for it, you're going to get the first term as 7 upon 91, right? Not very standard. However, if you evaluate the expression and then you finally approach the solution, because here you have to calculate 3 to the power 9, right, which is very trivial, which is very not trivial, right? It's not very trivial. So it involves some amount of calculations to get to the final answer, right? So I know you must be thinking that how are you going to do this calculation without the help of a calculator, right? However, you have to show some patience, okay, and have to do that calculation. Okay, so which is basically 729 into 27, and this is how you can approach 3 to the power 9. Okay, so if you do that, you're going to get this result, right? So from here, the final answer you're going to get is, so from here the answer you will have for the sum of the 9 terms is going to be 757. Okay, that is option number A, 757. Okay, all right, I hope this is clear. I hope this is clear to all of you. Okay, so let us now proceed quickly to the fourth part. Okay, now this is a very interesting problem, and that's the reason for taking this up over here. It is said that this terms x1, x2 and x3 are in geometric progressions, and 2, 7, 9 are subtracted respectively from these numbers, and the resulting numbers are in arithmetic progression. Okay, so if I consider this to be in arithmetic progression as AR square and AR cube, then if I subtract, so from A it is A minus 2, AR minus 7, AR square minus 9 and AR cube minus 5. These 4 terms are in AP, right? These 4 terms are in AP. That means the difference of this number is basically going to be constant. So from here I can easily do that. Okay, which is going to be AR, so this is 9 actually, right? Oh no, sorry, 7. AR minus 7 minus A minus 2, so that is going to be AR minus A and minus of 5, right? So we'll have the common difference to be as AR minus A minus 5, right? Now similarly, you find out the common difference from these two terms and equate it with this. So on simplifying this fundamental 2 equations, so we'll have one equation and another equation from the other part. So if you simplify that part, so in order to simplify, let us divide the expression. Okay, so one expression you will get like this, A times of R minus 1 times R square minus 1, and the other expression you will get as A into R minus 1 into R minus 1. So if it's divided, you're going to get as minus 9 by minus of 3, which is going to come out as simply as 3, right? So from this expression, you will have the value of R. So from this expression, you will simply get the value of R as 2. So once you get the value of R, you can substitute in any of this expression to get the value of A, which is going to be minus of 3. Okay, so if you simplify the value of A, you will have it as minus of 3, right? And similarly, then you can try to find out the product of these values, and ultimately if you solve it, the final expression or the answer you're going to get is option number B, that is 216. Okay, I hope this is clear to all of you. Is this part clear? Is this part clear? So let us now move quickly to the fifth problem. Okay, so I assume this is clear. So let's move to the fifth problem. Okay, so try to solve this problem. Again, very much not that simple, but however I have to make it simple. Okay, so how do we solve this problem? So first of all, try to write down the given expression in terms of the shorthand notation, that is r going from 1 to n. This can be given as 4r, because you can see these values are basically changing, right? So 4r divided by 4 plus 3r square plus r to the power 4, right? So this is what is given to you, right? Now how do you solve this problem? The simplest way to solve this sequence is try to simplify this sequence by using method of difference. Okay, so try to use the method of difference over here. How and why do I approach this problem by method of difference? You will try to understand, because whenever we get this kind of expression, our first thought is basically try to simplify this expression in terms of partial fractions. Okay, so in that partial fraction, try to make it in some form where it is like p of r minus p of r plus 1, like this kind of form. So I'm trying to express this particular summation in this particular format, right? So if I try to do it over here, so if I try that, so my summation is going to become something as, so this is basically, I can simplify by taking 2r upon, so r square plus of 2 whole square of it minus of r square. Okay, this is how we can simplify. And what I've done is I've taken 2 common. Okay, so 2 times of summation of, now this 2r, I'm trying to write this 2r in terms of this expression, that is something as r square plus 2 plus r minus of r square plus 2 minus of r. Okay, and then whole divided by, this expression is like a square minus b square, so that is going to be r square plus 2 plus r multiplied with r square plus 2 minus of r, right? And then we can simplify. This would be simple equals to 2 times of summation of 1 by r square plus 2 minus of r minus of, so now we are able to separate this in terms of 2 term difference, right? 1 upon r square plus 2 plus r, right? Simple. So if this is p of r, this is p of r plus 1. Okay, that is the main idea over here. Now since we have to find out the summation for r going from 1 to 20, so we have to take the sum of the 20 term, or the first 20 terms. Then we know that these are basically all the, so if I write the first term, the t1, and this is t2, similarly t2, t3, so what you can see, these terms are going to get cancelled out, right? So ultimately the t of 19 also will cancel out, and only we will left with t of 20, right? So t1 and t20 will be left out, so the result is going to be 2 times of t1 minus t20, right? So that if you evaluate, so finally you'll get the result as 1 by 2 minus 1 by 422 and whole multiplied with 2. Okay, so this result is going to be equal to something as 210 by 211, because you have to express this result in terms of m by n where m and n are co-prime, right? So you can see these are 2 co-primes, which is basically equal to m by n result, right? So from here m plus n is equals to 421. So finally we get the result as 421. The sole purpose of showing you this question is to recall the concept of method of common difference. Okay, so the result is basically going to be option number B. Alright, so these are the few simple problems that we have discussed so far in today's lecture. However, there is one more problem that I would leave up to all of you to solve. So this is a problem that you can solve as a homework problem. Okay, so please try to solve this problem in the homework, and do let me know whatever answer you are getting in the comment section. Okay, so with this part we are done with our revision of this topic of sequence series. Okay, so I hope this particular class helped you in brushing up over the basic concepts. However, there is one more important question, and this is a question which is basically was asked in JEE Advanced and has been repeated many times in JEE Mains. Okay, so this question is also an homework problem, and it's a very simple problem. So you have to find out the number of elements in the union of these two sets, right? So you have to apply some of the idea of the set theory to approach this problem. Okay, so these are the two problems that you have to take up as a homework problem and try to solve them. This will actually help you to recap the entire chapter of sequence series. Okay, so if you are done by this and must have also revised to the basic lecture notes, and please also try to make short notes along with this particular lectures. Okay, that will actually help you out to prepare for your JEE Mains. And if you are done with that things, I think you will be able to do good in your JEE Mains. So with this part, thank you, and I hope to see you soon in our next